Hi everyone, welcome to Xcoding with Alfian. This is the part 4 of building stocks app series using Swift Charts and SwiftUI. In the previous part 3 of the video, we have successfully implemented the stock ticker view containing the detailed quote prices. In this part 4, we will focus on building the chart view for displaying the stock prices over a series of time. We will implement these features. First, create the observable object or view model to fetch the chart data from Yahoo Finance API. Second, create a chart view with various built-in marks such as line mark, area mark, and row mark. And third, we will implement a custom chart plot content style. And for the next step, we will also implement a custom X and Y axis marks and scale to customize the ticks and labels in our chart. And finally, we will add a chart overlay, which we will put the drag gesture recognizer, so when the user is dragging on the chart, we will display a vertical rule mark containing the prices at the selected timestamp. If you haven't watched the previous video in this series, I really encourage you to watch them before. I've also provided the GitHub repo containing the starter and complete project for this video. And all of these links, the playlist, the GitHub repo, I've provided them at the description below. Let's begin and start coding. So, as Swift Charts itself is a very big and recent framework, I won't be able to cover all the fundamentals and details about Swift Charts framework in this video. I will mostly focus on the implementation of how to render the stocks charts using Swift Charts. So I will share all the references that I used to learn about Swift Charts. Let's begin from the official documentation from developer.apple.com. This is the official one. It provides the framework overview, all the API documentation, the struct, the properties, and it provides this very good article as well for creating a chart using Swift Charts. This provides a high-level overview on how to draw a various chart using various marks. You can simply copy or paste this into your playground and see the rendered result. Okay, and it also provides the sample code for building complex and interactive charts using Swift Charts that you can also check. You can just run this using your simulator or in your iPhone. And other than that, I also learned these 3 amazing WWDC22 videos. This one is the introductory one, Hello Swift Charts. This is a very good introductory video for the Swift Charts framework. And the next one, Swift Charts Raise the Bar. So this is the next step on how we can use Swift Charts to represent a complex data sets through a wide variety of chart options. And related to the UX, there's this video, Design App Experiences with Charts, if you want to learn about how to enhance app with charts to communicate data with more clarity and appeal. Okay, so I will share all the links to these references in the video description below. You can check them by clicking on the link. Okay, let's begin by clicking this stocks app series folder. So this is the GitHub project. It has 4 parts. In the previous video, we have completed this part 3, stock ticker sheet UI. So for this part 4, we will use this as the starter project. So click on the part 3, stocks app, and click stocksapp.xcode project to open in Xcode. And make sure you install Xcode 14 to follow along. So the first thing that we are going to do is to create a model to represent the chart view. It will contain properties such as the series of data, the x-axis marks and y-axis marks, line color, and others as we add more features later. So in the models folder, create a new Swift file. Give it a name of chart view data. And let's import SwiftUI in here. The color struct chart view data. Make it conform to identifiable, and let's add the ID to conform it. This is the requirement for the identifiable, and for the ID we are going to just assign it with the default UID value. Before we continue, let's create another struct. Chart view item also conforms to identifiable, and let's also use the UID, default UID as the ID property, and this will represent the indicator, will contain the timestamp with the type of date, and the value with the type of double. This value will be representing the price. So the chart view item represent price at a given timestamp. Okay. Continuing on the chart view data, let's go back. Let's declare let items, and the type is chart view item array. Okay. So this will be the initial properties. We will add more properties later when we continue to add more features later. Okay. That's it for the chart view data. Now let's begin by creating a view model, chart view model. This view model is responsible to fetch the chart data from the Yahoo Finance API. So it will interact with the stocks API, and then it's going to transform the data so it can be presented in the chart view. So basically it will going to transform the data into this chart view data. Okay. So in the view models folder, create a new Swift file, give it a name of chart view model, and import SwiftUI, and let's also import the Exia Stocks API. Let's begin by declaring a class, give it a name of chart view model, make it conform to the observable object protocol, and let's also add the main actor annotation to make sure all the async task runs in a main thread. Let's declare the first publish property for this. So we're going to use fetch face as always. This fetch face will provide various status, loading, empty state, or the state with the data. And this is generic, right? So fetch face for the value is going to be chart view data. Okay, this is the model that we have created before, and let's assign this with the initial state. Okay, and let's also create a property, computer property chart with the type of chart view data, and we can basically use this fetch face dot value. This will return the optional chart view data, and this chart, it will be optional. Okay, next is we're going to have ticker. Okay, the stock ticker that we're going to inject in the initializer, and we're also going to have API service, which is the stocks API protocol that we are going to use to call the API service to fetch the chart data. And I'm going to declare this app storage property wrapper with this key selected range. So this will be the selected range for the time interval, 1 day, 1 week, and we are going to persist the user selection in the user defaults using this app storage property wrapper. Okay, so the key is selected range, and let's make this private and declare with the underscore range. Okay, we're not going to expose this. So the default value, let's assign it to 1 day raw value. Okay, and next one, we are going to declare a published var selected range. So we're going to expose this chart range. The default value is 1 day as well, and we are going to declare a date set. So basically, when someone set this selected range property, we are going to update the app storage. Okay, underscore range with the selected range raw value, so it will be persisted in the user defaults. Okay, we have these properties. Next is let's declare the initializer in it we're going to inject the ticker, of course, and the stocks API, and we're going to use the protocol stocks API. And let's also assign a default value. This is the concrete implementation XCS stocks API. Okay, and let's assign them to the associated property. First one is the ticker, and next one is the API service, stocks API, and selected range. So I think for better uniformity, let's change this parameter to API service. API service. For selected range, we just going to initialize the chart range enum using the raw value, and we're going to get it from the range. Okay, and if it is nil, we're just going to assign 1 day as the default value. Okay, so by default, when this chart view model instance got initialized, it's going to get the initial selected range value from the user defaults. Scroll a bit here. Can we make the font a bit bigger? I think. Sorry, I think the font is too small before. And let's declare also it's going to be public. Func transform chart view data. Okay, this is going to accept the chart data. Okay, chart data. This is the data that we get from the stocks API later, and we're going to transform it to the chart view data. Okay. For the initial implementation, we can simply use this data, and there's this indicators array, and we can map this to the chart view item, assigning the timestamp, and we're going to use the closing price for the value. Okay, so I'm going to use close, and let's return the chart view data with the items. Okay, and continuing on, we need to declare the method to fetch the data from the stocks API. So let's declare fetch data with the empty parameter, and let's make this an async function. Okay, let's declare a do try fetch, and then in the fetch block we can simply assign the fetch phase with the failure state, passing the error. Okay, let's implement the do. So for the do, first one is let's set the fetch phase to fetching. Okay, and let's capture the range type before we perform the await. Okay, and let's declare chart data and invoke try await, and here we're going to invoke API service fetch chart data. Okay, obviously this is going to give an error before we haven't implemented this in the stocks API. So let's implement this first. Go to the XCS stocks API, right? Okay, and let's see at the interface. So let's grab this one, fetch chart data. Okay, and let's put it into our own protocol, stocks API. Okay, and as you remember, we have this mock stocks API. We also need to provide the default implementation. Let's just return nil for now. We are going to stop the data later. Okay, and fetch chart data. Now we can invoke fetch chart data, and then we're going to pass ticker dot symbol, and for the range, let's pass range type. Okay, so this is an async await function. So after it completed, there's a possibility that the selected range has changed. So that's why we have captured this range type. So we're going to use guard if the range type is equal with the selected range, right? If it is not have been changed while this is in process, we're going to just this not equal, we're going to return. Okay, we're not going to continue. So it must be the selected range must be have changed, right? User have selected a new value. Next, this chart data itself is optional, right? And let's use if let chart data. In the if block, we're going to assign fetch phase with success. Okay, but remember we need to transform it. So let's invoke transform from chart view data, passing the chart data. And in the else block, it means that the chart data is nil. Okay, so we pass empty. Means that there is no chart data related to the type ticker symbol. Okay, let's try to build first. Okay, next let's add some stubs for the chart data given a chart range. Okay, so you know that the chart range we have this 1 day, 1 week up to max. We're going to stop the data, provide a chart data for each of these case. So inside this mocks and stubs folder, first let's create a new Swift file. Give it a name of chart plus stubs. Okay, for this chart plus stubs, I'm going to copy and paste all the code inside inside the completed project. So what you can do is just to open the part 4 in Xcode and find this chart plus stubs.swift file and just copy and paste everything inside this file. Okay, so okay, I have copied and pasted this. So let me explain this. First, we have the extension for the chart data. Here we have the static var for stop 1 day, stop 1 day, ongoing 1 week up to the 5-year, 10-year max. Okay, and basically this we will pass this chart stub. So what are these? This just a let containing the JSON string. So we have everything from 1 day ongoing, 1 day, and up to the maximum 10-year and max. Okay, I have copied and pasted all the stubs for you, so you don't need to do it by yourself, right? Okay, you just need to copy and paste this, and basically you will have all the steps that we can use to stop the value in the SwiftUI preview. So for the preview, we won't call the real network API, the Yahoo Finance API. Okay, so this is everything. And if you want to go into detail, then yeah, just take a look. I will continue. Basically, given a chart range, we can have this stub based on each of the case. 1 day we return stop 1 day, 1 week we'll return stop 1 week up to the max. Okay, so how do we use this? First, we'll go to the mock stocks API. So we already have this. Now we have to declare this mechanism property that we can use to stop. Give it a name, stop fetch chart data callback. Okay, this is a closure. So there's one parameter, chart range, and this is an async throwing closure. So let's declare async throw keyword, and the return type is chart data optional. Okay, and let's make this force unwrap optional. We will provide a default value. The default value itself will be the chart range dot stop. This is the computed property inside the chart range dot stop extension. Okay, so that is the default value, but you can also stop this if you don't want to use this chart range dot stop. We will do it later for the 1 day ongoing. Okay, I will show you how. And then inside in this fetch chart data method, you can simply invoke try await stop fetch chart data callback passing the range. Okay, so we have this range from this parameter range, right? We can pass it in here. Okay, that's it for the mock stocks API. We have the stubs as well. Now we need to finally create the SwiftUI view for the chart view. So inside the stock ticker sheet views, create a new SwiftUI view. Give it a name of chart view. First, let's import HCS stocks API and also import Swift. Sorry, I think charts, not Swift charts. Okay. And first, let's declare a let data. This will be the chart view data. Okay, let's implement the preview. Okay, so first, let's create a helper view to help us render the chart view preview. So here, let's declare an if debug condition. Okay, if debug macro, sorry, and declare a struct chart container view underscore previews and make it conform to the view protocol. And here we will have a state object var VM. This VM will be chart view model. We will inject this letter with the mock stocks API and stop for the fetch chart data. And let's declare as well the title, the title string, and the body, our body. First, let's declare a vstack in here, and inside the vstack, let's pass the title, and let's use if let chart view data equal to vm.chart. Then we're going to declare the chart view passing the chart view data. Okay, and then let's add several modifiers to the vstack. First one is padding for all edges, and let's limit the frame with a max height of 272, and let's also pass a preview layout size that fits, and let's set the preview display name passing the title. So we will have several previews based on the stub. And let's add the task modifier invoking the await vm.fetch data. Okay, this is the chart container view previews. Next, let's go to this chart view previews. In here, first let's declare a static let all ranges. It's going to be chart. So for the all ranges, we are going to declare chart range all cases for the default value. Then we need to separately handle the 1 day ongoing. Okay, so let's give it a name of 1 day ongoing, and here we're going to just assign it with the chart data dot stop 1 day ongoing. Now let's move on to the static var previews, but before that, let's declare a static func chart view model. So this will give a chart view model given the chart range, and then we also pass the stub, which is the chart data. It will return chart view model. So in here, let's declare a mock stocks API. Mock stocks API, initialize it, and then mock stocks API stop fetch chart data callback in here, and over here just ignore this and just return the stub. And let's declare the chart VM, chart view model. For the ticker, let's just pass the stub ticker, and for the stocks, For the API service, let's pass the mock stocks API. Okay. And finally, we can return the chart VM. Okay, let's go to the previews in here. Let's declare for each. Let's pass the our ranges array. And then in here, we can simply declare this chart container view previous. Okay. And here, I'm going to just pass the VM, invoking the method. For the range, just pass the $0, and for the stub, $0.stubs. For the title, it's going to be, so actually the chart range have the title property that we can also use. And for the 1 day ongoing, we can handle that differently in here. Chart container view previous. Let's also call this static func. And for the range, we need to pass 1 day. And for the stub, we need to pass the 1 day ongoing. For the title, give it a title of 1 day ongoing. Okay. So let's try to build. Okay. So there are no errors. Okay, build succeeded. Let's refresh the previous. Okay, we have the preview rendered in here. So 1D, 1V, 1M. So now let's begin implement the chart view. Okay, now inside the chart view, I will declare a private var chart sum view. Okay. And let's declare this in the body. So this will help us later when we will add modifiers, additional modifiers to the chart. This will help us organize and clean up the code later. Okay. So inside this private var chart, I'm going to declare this chart. So this is a SwiftUI view that displays a chart. Okay. So basically, we need to pass the view inside this view provider closure. And so inside this chart, we can declare several marks such as line mark, area mark. So first, we want to render all the items inside the data. So we're going to use for each, passing the data.items. And we are going to use the line mark. It's a chart content that represents data using a sequence of connected line segments. So there are several initializer here. We are going to use this X and Y. So this accepts a plottable value for the X and Y. As far as I know, the number and the date is conforming to this plottable value. So we can pass either the date or number. Okay. So for the X, let me clean this a bit. Let's pass this value. And for the value, let's provide a label time. And for the plottable value, let's pass the time item dot. So we're going to use this timestamp. Okay. $0 the timestamp. So the X represents the time and the Y will represent the price. And for the price, we can pass $0.value. Okay, as you can see here, we have the chart rendered. But if you see, it is a bit weird, right? The Y starts from 0 to this 150. Okay, so but actually in the stocks chart, right, usually it starts from the lowest price up to the highest price. So luckily SwiftUI provide a mechanism for us to handle the scaling for each of the axes. So this is very simple to implement. So inside this chart, let's add this chart Y scale. We want to scale the price, right? We don't want it to start from 0. So let's use this chart y scale domain. So for this domain, we can pass the minimum price inside the items array up to the maximum price in the item array. So that is data.items, and let's map this $0.value, and from this array we can, sorry, why it's giving this error, we can pass min. Okay, this is the minimal value. Then you're gonna use this range and pass data.items.map value and max. So this is optional, but for now let's just force unwrap it. Okay, as you can see, it is nicely scaled. The y-axis, it is starting from the lowest price up to the highest price. As you can see from this render chart, Swift Charts is doing a great job to automatically provide all of these ticks and labels for the x and y axis marks, right? If you see here for 1 day, it is using able to infer that the x is the date, and then it's formatted this showing the hour, right? And let's say for 3 months, it is able to use this format this to month September, October. For 2 years, it's using showing the month and the year. As you can see the interval as well, like for 10 years 2014 and then 2016, so it's 2 years interval. Even for the prices as well, I think for the y-axis. So I think out of the box we don't need to do anything for these ticks and labels, but actually SwiftUI provide a mechanism for us to customize the ticks and label for each of the axis marks. For now, I'm going to show you a very simple example on how to do that. This is just an example. So here, chart x-axis, we can use this, right? So basically, using this modifier, we can configure the axis marks here. Just record the axis marks. There are several options, but I'll just give you the simplest one for the x-axis. So we know that this is the date, right? So we can pass the date format style in here. And for the date, we can say we want to omit the date. We want to shorten the time. Let me skip the locale. And for the time zone, we want to so this is a Nasdaq based stocks, so it should be this value. And we don't need to pass this. Okay. So if you see in here, it is able to format this value, right, based on this configuration that we pass in the chart x-axis. As you can see here, 12 p.m. So it starts from 9:30 and 3 p.m. up to 4 p.m. So this is the option that we can use. We can also tell the x-axis when to strike the value in here. So is it by 1, by 2, by 1 year, by 1 day? That is the option. And later we will implement this chart x-axis using a custom logic, so we can mimic the ticks and label used by the native Apple Stocks app. If you see the native Stocks app, if you play around with the day, for the year, month, you will see the interval that is shown in there as well as the date format. We will be trying to mimic that. Okay, so for now, let's just ignore this and move on to the next feature. Okay, we will implement that custom x and y axis mark later at the end. Okay, before we continue, I want to change the scheme of the preview to dark appearance. So click here and then select dark appearance and toggle this on. Okay, now it's showing the preview in dark scheme, dark appearance. And next we are going to implement a custom chart plot style, which we can use to configure the plot area of the charts. So basically we want to add a border above these tick labels in the x-axis, and also a border here at the left of these y-axis tick labels. So we can use this modifier chart plot style. So this will pass we need to pass a closure, and basically the parameter is chart plot content, and we need to return the view. Okay, and I will declare a separate private func for this. So private func chart plot style with one parameter plot style and chart plot content as the type. It returns opaque view, some view. Let me scroll this, and inside this chart plot style we can just invoke this private func chart plot style and pass the plot content. Okay, now let's begin configure this plot style. Maybe it's better to name this chart plot content. Okay, plot content. So this is just like a SwiftUI view. You can add a frame. I want to add a frame with the height of, I want to limit the height to 200. And next I want to add a overlay. The overlay, I'm going to pass a rectangle in here and set the foreground color to gray with the opacity of 0.5. Okay, and here's the trick. I'm going to add this mask modifier. Okay, and I'm going to pass a C-stack in here. Okay, scroll down, and in this C-stack I'm going to declare a V-stack, declare a spacer inside the V-stack, and then declare a rectangle with the frame of height equal to 1. Okay, as you can see, now we have this border at the bottom above the x-axis ticks labels. Okay, now for the y-axis border, let's declare a h-stack spacer inside the h-stack, and then let's also use the same trick, rectangle, and set the frame with the width of, I want to pass 0.3. Okay, as you can see, it renders this line, the border, at the left of the y-axis ticks and labels. Okay, that is for the chart plot style. Next, we're going to add the line color depending on the stock prices inside the array. Okay, whether it's going to be green or red. We'll have to implement that logic, and let's go to the chart view model to implement that. In here, let's declare a func get line color with one parameter, chart data. Okay, it's going to return the color, SwiftUI color. So basically the logic is we're going to check the last price in the array. If last data.indicators.last, and we are going to use the closing price. Okay, so if this exists, we're going to have a separate logic for the selected range is 1 day, right? Then we're going to compare it with the previous day closing price. Okay, let me name it graph close, and to grab the previous day closing price, I'm going to use data.meta, and then there's this previous close. So if the selected range is 1 day, we're going to basically use this logic. The last price, today last price in the array, greater than the previous close. Okay, if it is true, this statement, if this last price in the current trading day is greater than equal the previous day closing price, then we are going to return green. Okay, else we're going to return red. It means that the current trading day price is lower than the previous close day. Okay, that is for one day. And next is for, let me scroll a bit here, for the else, for all the other selected range. Here we're going to use else if flag. We're going to grab the first price in the array, the current array, data.indicators the first close, and we're going to basically use this. If the last is greater than the first one, we're going to return green. Okay, else red. Okay, that's the logic to determine the line color. And now let's return blue for the default in case this is not valid, right? All of this if statement. Okay, now we have this get line color. Now to represent this in our chart view data, we need to add a property here. So below these let items, let's declare a let line color with the type of color. Okay, and basically in here, chart view data, you can pass additional parameter line color and invoke get line color passing the chart data. Okay, now we have line color inside the chart view data. Now let's add this to the chart view. So to modify the line mark color, it is very easy as well. Using Swift Charts, simply add this modifier foreground style, and we can simply pass data.line color. Okay, so this is red. So probably if I use 5 years, it will be green. Okay. So I'm using Apple stocks data for stubbing this. As you can see here, for 5 years, it's going to compare this and this. Okay, 2017, and then the latest one. Okay, this is green. So for the one day, it's going to compare the latest one with the previous day closing price. Okay, so in this case, probably the previous day closing price is higher compared to this, so that's why it's red. Okay, that is for the line color. Okay, for the next one, we are going to add a gradient. So if you look at the stocks app, the Apple, below this line mark, there's a gradient that fill this area, as you can see here. So we are going to implement that, and we are now going to use the area mark. So this is another type of mark that we can use in the chart. So remember that in Swift Charts, we are able to combine multiple marks inside one chart. Okay, so let's see how to implement that. And that is actually very simple to implement. Okay, so below this line mark, we simply declare this area mark. This is the chart content that represents data using the area of one or more regions. Okay, so for this, we are going to use this X for the value. We are going to also use X time, passing the timestamp. So we need to use this $0 timestamp. For the Y, I'm going to use Y start. Okay, Y start. For the Y start, I'm going to pass minimum. So it's going to start from the minimum value inside our items array. Okay, the minimum price is in the array. So we still need to map this to double first, and then invoke min here. For sure, we're going to refactor this later. Okay, we're going to put this data items.map inside the chart view data, but for now we're just going to use that directly. And for the yn, we're going to pass the maximum value. So for the minimum value, it's going to start from the minimum value based on the items inside the array, and for the maximum, we are going to pass the actual value for this item for each. Okay, as you can see, it now render this, fill this area below the lines nicely, right? But we want to render this using a gradient, right? So that is also very easy to implement using SwiftUI. We can use foreground style just like before, and we're going to use this linear gradient. Okay, linear gradient. So for the linear gradient, we're going to declare a gradient. Okay, and we're going to pass the array of color. Okay, the first color is going to be the line color, data.line color. Okay, whether it's red or green. And next one is clear. And for the start point, we're going to start from the top and up to the bottom. Okay, nice, as you can see, right? So basically it's going to be starting from this top red, then we're going slowing down until the background is transparent, clear, right? So you can pass another color if you want inside this array, but I think this very representative with the actual Apple Stocks app, right? Looks nice. Okay, and there's one more thing I think that I want to add in here. I want to add opacity of 0.3. This looks nicer. Okay, yes, we have implemented this gradient below the line mark using this area mark chart content. Nice, right? Okay, so next let's add a rule mark, horizontal dotted rule mark, showing the previous day closing price if the selected date range interval is 1 day. Okay, for the other date range interval, it doesn't make sense to show that dotted rule mark containing the previous day closing price. Okay, and also we're going to refactor this logic to get the minimum value, minimum price, or maximum price in the array of prices. We're going to abstract that into as a model. So let's implement that first. Go to the chart view data, and let's create another struct to represent chart axis data. Okay, so let's declare two property, axis start double, okay, and axis end double as well. And below this chart view data ID, let's declare the y-axis data first with the type of chart axis data. And below the line color, let's also declare a previous close rule mark value with the type of optional double. Okay, so those are the two building blocks that we are going to use for this rule mark. Now let's go to the chart view model first. Obviously it's going to give an error there as we need to add the missing parameters, missing arguments. So for the first one, let's implement the y-axis chart data method to compute the y-axis chart data axis data. There's one parameter, one input, which is the chart data, and the return type is chart axis data representing y-axis. Okay, so here let's begin by grabbing all the closing price in the array: data.indicators.map and zero.close. Okay, we get this. Now let's declare a var lowest. The lowest value will be the min inside the array. This is optional, so let's provide a default value of 0. Max is highest. Highest is going to be max. Okay. So also provide the default value of 0. And now we're going to have some logic. If the previous closed data exists, data.meta.previous close, and only if the selected range is 1 day, okay, we're going to apply this logic to modify the lowest or either the highest. If the previous close price is less than the lowest price of today trading day, right? We're going to set the lowest with the pref clause. Okay, that will be the exit start. Else we're going to set the highest else if the previous close is greater than the today highest trading price. We're going to set the highest to pref close. This will be the axis n, okay, for the y axis. And we simply need to return the chart axis data, and for the axis start it will be lowest. And let's add additional fraction that we will have later when you implement the custom y-axis domain mapping. Okay, just highest, just add it with the fraction of 0.01. Okay, that is for the chart axis data. Now let's declare this first. Yeah, y-axis chart data, and invoke this y-axis chart data, passing this chart data. And now we can add this parameter, passing this y-axis chart data. Okay, one more thing is this previous close rule mark value. Okay, let's also encapsulate the method to calculate that, separate function. Okay, so declare this func and give the name of previous close rule mark value with these parameters. First one is data chart data, and second one is the y-axis data with the type of chart axis data, and third one is selected. I don't think we need to pass selected range, sorry. And okay, there are two parameters. Return type is double optional. So here let's also check if the previous close exists in the data.meta previous close, and if the selected range is 1 day. Okay, the conditions are met, then we're going to continue, else we're going to return nil. We won't show the closing rule mark. And here's the logic. The current open parenthesis and y-axis data.axis start is less than equal to previous close, then and the previous close is less than equal to y-axis data.axis n. Okay, only in this condition we're going to return the previous close value. Other than that, we'll return nil. Okay, that is the logic to determine whether we show the previous close rule mark and the actual y value for that. Here we can simply invoke previous close rule mark value, passing the data and the y-axis data. Okay, let's name this y-axis data. I think. Okay, let's just use y-axis chart data. Okay. Now let's build this first. Okay, build succeeded. Now let's go to the chart view to implement the new properties. Okay, let me enable the preview. The first thing that we are going to do is to replace this chart y scale with data, y-axis data, axis start, and then use this range, data, y-axis data, axis end. Okay, this a bit cleaner compared to the previous one. Also, we can clean this area mark as well, this min. Let's replace this with the data dot y-axis data dot axis start. Okay, looks good, still working as expected. And now for the rule mark. So that is we need to basically use if let previous clause. If this previous clause rule mark value exists in the data, we're going to declare this rule mark. Okay, a chart content that represents data using a single horizontal or vertical rule. Okay, so for the as we want to show the horizontal rule, so we will pass the y. Okay, for the label it's going to be previous clause. For this value it's going to be the previous clause that we unwrap. Okay, nice. That is the line there. Let's style the line first. It's very weird having that thick blue line. So let's use the line style and pass the init. Okay, in this init we can pass the line width. Let's pass 0.1, and the dash, the dotted, let's pass 2. Oh, okay, this looks good. So this is the rule mark, I think this one, sorry, it's above 138 something. And let's also add a foreground style also, passing gray with the opacity of 0.3. Okay, looks good. Let's clean this bit. And yeah, that's it. We have implemented this rule mark to show the previous clause training day press for the 1 day dead interval. Nice. Okay, so next we are going to implement the drag gesture to our chart view. So when the user is dragging inside this chart, we are going to show a vertical rule mark with the text containing the price as well as the timestamp label. Okay, let's begin implementing that. So the first thing that we need to do is we need to have some state. Okay, when the user is dragging, and we're going to put this inside the chart view model. So below the selected range publish property, let's create another publish property wrapper part. So we're going to capture the selected text. Okay, and for the value we are going to use this any plotable. We are not we're not using a concrete type. Basically we use the protocol any plotable. Okay, so that is the state. I think to use this any plotable we need to also import charts. Okay, this works, and we have that state to determine where the user is dragging. Next is we need to have a compute property. Just declare this selected x rule mark. Okay, so basically we will capture the x position, right? So for this selected x rule mark, we're going to declare a tuple, and the first value is date and second one is a string. Okay, this is optional as well. And let's declare dot let selected x. We're going to cast this as date. Okay, and we're also going to unwrap the chart in case one of them are nil. we just return nil here. And then we need to declare the index. We need to grab the associated index inside the indicators array given the user selected X. In this case, it's going to be the date. But the problem is because the selected X value, the timestamp, is not a discrete value, right? Because the user can smoothly drag around. So it's not a discrete value. So if we try to just loop the array and find the particular value of the selected X, it won't work properly, right? So luckily, Apple provide this date bins. It's a collection of bins for a chart that plots the data against dates. Okay, so other than that date bins, Apple also provide number bins. Okay, so how does this works? Okay, so basically here we're going to use these thresholds and pass the chart dot items dot map. We're going to give the array of the date timestamp, right? So given this and the selected X, right? Because remember the selected X won't be a discrete value, right? Because it's going to be like a fraction when the user smoothly dragging, right? So there's a API method that we can use to infer, right? To find the best index given that particular timestamp inside these date bins. Okay, we just pass the selected X. This is going to give us the index. Basically now we can return the selected X and we can return the prices given this index. But we are going to format the double using this person.2f token, and we are going to give this chart.items using the index.value. Okay, that is the selected X rule mark. Now we can go to the there's another compute property, foreground mark color. Okay, what will be the color of that foreground mark color? So if the selected X, okay, if the selected X is not nil, right, it means that the user is dragging. In that case, we will show all the lines, all the marks with cyan color. Okay, with the cyan color. Other than that, we are going to use this chart.line color. If it is nil, we're going to use cyan as well as the default value. Okay, so basically when the user is dragging, the color for everything, the line marks, the area marks, the rule marks will be cyan. But other than that, we're going to grab it from the chart.line color. Okay, as simple as that. Now we're going to go to the chart view. Okay, so in here we need to pass this unobserved object. Okay, because we need to update that selected X value when the user is dragging, so that's why we need to pass this observed object. Okay, and we will pass the chart view model. Now we need to handle that in the preview, right? So in the preview here, we need to pass this VM, okay? And basically we can pass that state object that we already have. Okay, let's build this first. Okay, the build succeeded. Okay, so now let's scroll up to the chart view. And first let's declare a private func on change drag. Let's declare 3 parameters. First one is value. This is drag gesture.value. Second one is chart proxy with the type of chart proxy. It's a proxy that you use to access the scales and plot area of the chart. And third one is geometry proxy. Okay. So let's the implementation empty for now. And now we're going to add the chart overlay. Okay, so in this chart overlay, it will give us basically the chart proxy. It's the parameter. So proxy in, and first let's declare a geometry header, and let's give the name of jproxy for the geometry proxy. And inside the geometry header, let's declare a rectangle, and let's make this transparent using this fill, passing a transparent color of clear. And let's also add a content shape, passing rectangle. Okay, to make sure it accepts the gesture successfully in this rectangle shape. Okay, next we are going to attach a gesture to this rectangle, and we are going to use drag gesture. Set the minimum distance to 0, and in here we need to add several actions. First one is on change. For on change, we can simply invoke the method on change drag, passing the value $0. Okay, chart proxy, let's pass proxy, and for the geometry proxy, let's pass g proxy. Okay, that is for the on change modifier in the gesture. This will be invoked as the user drags. Okay, and next one is the on ended. This will be invoked when the user stops dragging. Okay, let's ignore the parameter, and we can simply assign the vm.selectedX to nil. We will basically remove the selected X state. Okay, that's it for the overlay. We have attached the drag gesture. Next is we need to also update some of this. So we won't be using the line color. We are going to pass vm dot foreground mark color. Okay, we are going to grab it from the VM. This line mark. What else? This one also. Let's change this inside the area mark gradient. Change to vm dot foreground mark color. Okay. What else? I think that's it. Okay. Now we need to render the vertical rule mark in case the user is selecting dragging. Okay, so let's use this if let, and let's break down the tuple selected X and text from the vm.selected X rule selected X rule mark. Okay, this one. Okay, so here we're going to declare a rule mark, and as we're going to render a vertical line, we're going to pass the X. The X itself, let's pass the value selected price, so the selected timestamp, and the value will be the selected X, the date, and let's also set the line style, passing line width of 1. Okay. And next one, let's add an annotation to show the text. For text, let's pass the text. Let's set the font for text to system size of 14. And let's set the foreground color for the text to blue. Okay. And let's also add the foreground style for the rule mark using vm.foreground mark color. Okay, I think let's try to build first, make sure there are no errors. Okay, so this will be rendered if the selected X exists. Okay, so now we need to handle this on change drag to assign the selected X based on the user coordinate position when they are dragging inside this chart. Let's begin by declaring a let X current X position in the coordinate. So to grab it, we need to use the drag gesture current location.x. Okay, and we need to basically subtract it with the geometry proxy. and we need to use this chart proxy dot plot area frame dot origin dot x. So this will give us the x coordinate that the user is currently dragging. And now we declare the if let. First one is timestamp. We need to grab the selected timestamp at the x-axis. So to do that, and also we need to explicitly say that this is a date. Okay. We need to use chart proxy and then use this value at x. Okay, it returns floatable. That's why we have to cast this as date, because we know that the x-axis is driven by the timestamp, which is date. Okay, at x you need to pass the x current. Okay, next we have to check several value as well. Let's get the start date from the data.items.first.timestamp. Get the last date as well from data.items.last.timestamp. And we need to do some check here. The timestamp, selected timestamp, is greater than equal to start date, and timestamp is less than equal to last date. So we have to make sure that the selected timestamp is within the chart x scale, okay, with the start and the end timestamp. We need to assign the selected x state with the timestamp. Okay, I think that's it. Now we have to test this by dragging here in the preview. Let's resume the preview. If you use the simulator, hold right click. Nice, it is showing the mark, right, as you can see in here. Nice. So this is the price at a given timestamp, right? Okay, looks amazing. One thing that I want to add a little bit of padding here, because currently this overlaps the title in the preview. Okay, now it looks great. Amazing. Let's try again. But actually there's issue if we try to drag in here. As you can see, there's some anomaly, right? The line is moving, right? The chart is moving. So why this happened? Because we haven't limit the x scale. Okay, for the y scale we already provided the axis start and the axis end, but for the x-axis we haven't done anything, right? So for now, to handle that issue, you can pass the domain. Okay, and for now let's just pass the first timestamp, right? We will refactor this of course later. .data.items.last.timestamp. So this will be the x scale. Okay, we're going to limit this starting from the first date until the last date in the array. So if you try to try again, you see now it works perfectly, right? Nice. So that is it for the drag gesture for showing the chart price annotation. Chart price at the selected x. Okay, so next let's integrate this chart view to the app inside the stock ticker sheet view. Okay, let's navigate to the stock ticker view. Okay, and now we need to declare the state object here, chart VM, and the type is chart view model. Okay, and next we don't need this selected range anymore because we already have the selected range inside the chart view model. Okay, next we are going to change this to pass the published property, the binding of published property inside this chart VM. Okay, so this will modify bind the value for inside the selected range in chart VM. Okay, now we need to update the mock in here. Okay, because it misses the chart view model. Let's declare a static for chart VM in here, chart view model, and just initialize the chart view model with the stub ticker. And for the stocks API, sorry, not stocks API, API service, we're going to pass the mock stocks API. Okay, now we need to pass the chart VM here. VM. So we have 4 previews that we need to pass. Okay. Now let's build this first. Okay, build fail. Of course it fails because in the main list view, we also need to update this. We need to pass the chart VM, okay, inside this sheet modifier, the stock ticker view, chart VM. Just initialize chart view model. Okay, for the ticker, let's pass the ticker in here from this. For the stocks API, not stocks API, for the API service, let's use the quote VM stocks API instance. Okay, don't forget to add a comma. Let's build again. Oh, the ticker itself is, we don't declare the parameter, so let's just parse $0. Okay, it will build successfully. Now we have passed this. Now it builds successfully. Let's go back to the stock ticker view and let's navigate to the, I think we have the, okay, we need to replace this placeholder with the chart view. Okay, let's begin by declaring a view builder in here and create a private chart view, some view. Okay, we are also going to use the fetch face. So use switch and invoke chart VM dot fetch face, and in case of fetching, we're just going to show the loading indicator. And in case of success, let's grab the data and let's declare the chart view, passing the data, and we can also pass the chart VM. Next one is the failure. Let's grab the error and declare the error stat view. Let's pass the error. And in here, I'm going to use the string interpolations chart and then also pass the error dot localized description property. There's one more case which is default. In that case, I'm just going to declare an empty view. Okay, nice, right? So basically we have two synchronous data. One is the chart and one is this quote details, right? Now we have to replace the placeholder here. In the previous video, we declared this text passing chart view placeholder. Now we can replace it with the chart view property that we have created. And next one, we need to also update the task modifier, right? We need to invoke the chart VM fetch task. fetch data, right? So first one is if the quote VM.quote is nil, okay, we're going to fetch the quote VM fetch data, and we're going to outside of the if block, we're going to invoke await chart VM fetch that to fetch the chart data. Okay, as you can see now, it shows the chart there nicely in the preview. And one thing, whenever this new date interval is selected in here, right, we need to also retrigger this task. So to do this, we can pass the ID modifier, which is an equatable. So let's pass the string interpolation of chart VM dot selected range. I don't think we need to use string interpolation, sorry. Just use chart VM dot selected range dot raw value. So whenever a new range is selected, it will trigger this new task. So that's why I check this quote VM. It's already fetched. I won't fetch the new one. Okay. But for the chart data, I will always invoke the fetch data to fetch the new chart data given a new date interval selected. Okay, now we have that. Maybe we can try change this. Nice, it works fine, right? Whenever I change this date interval in here for the picker, it will update the chart. Let's also test the drag gesture. Nice, it works nicely. Okay, let's reset back to 1 day. If you look at this closely when I do this drag gesture, so as you can see, it looks like the price overlaps with that line. Also, we want to show the exact time. We will show a label, and basically we want to hide that picker when the user is dragging, just like the Apple native stocks app. Okay, so let's try to implement that. Now the first thing that we're going to do is go to the chart view model, and then here above the init, let's declare another private let selected value date formatter. We need to format the date. Let's pass a closure. Okay, so let df that formatter df, and we want to set the date formatter date style to medium. Okay, we will show this the date style with the medium style. We will format the time. Next one is, let's create another var in here, selected x that text is a string, guard let selected x equal to selected x as to date, and the chart also a web date, else we'll turn an empty string. So now let's for this if the selected range is 1 day, okay, or the selected range is 1 week. In here we're going to set the formatter time style short. Okay, we'll only show showing a short time style containing the hour and the minute. Okay, but in the else block, right, other than this 1 day and 1 week, we will set the selected value that formatter time style to none. Basically, we won't show the hour and the minute. Okay, in that scenario. Next one is we need to, let me scroll a bit. Just like before, we need to get the index, the price using this dat bins. chart.items.map timestamp, and then we just invoke the index for the selected X. So this should be give us the index, and then we can grab the item from the chart.items using the index, and we can basically use the selected value that formatter invoking string from passing the item.timestamp. Okay, this is the label that we are going to show when the user is dragging the particular timestamp. Next one, we will have another var in here, selected X opacity. This will be used to hide some of the components such as the dead picker when the user is dragging. Okay? If the selected X is nil, okay, we're going to show it, else we're going to hide it. Now we have all of this. Let's go back to the chart, not chart view, stock ticker view. Okay, let me change this color scheme also to dark. Okay, it is easier on the eyes. Okay, next is we need to update this. Basically, first we need to declare a C stack. Okay, we're going to put this dead range picker view inside a C stack. We will see why in a second. Let's also add an opacity. Pass chart VM selected X opacity. So when the selected X is not nil, then we're going to hide this. Okay, and on top of this, we're going to declare the chart VM text, passing chart VM dot selected X date text, and passing font headline. Okay, and let's also set the padding to vertical of 4, and for the horizontal we're using the default value. Also this divider, and the opacity, passing the chart VM selected X opacity. So when the user is dragging, we're going to hide this. Okay, now we have to try this, right? Let me try to drag. Okay, as you can see, when I drag here, it hides the dead picker and it shows the dead label at the top, right? This is for 1 day. It shows the date and the time as well. And let me change to, for example, YTD. Okay, so this should not show the time. As you can see, it's not showing the time, right? It's only showing the date. Nice. So we have updated the UI to handle this. Now this is very, we are like cloning the native Apple stocks app. Okay, looks nice, everything is working. Okay, so yeah, we have implemented this chart view inside this stock ticker view, but there are some ongoing problems actually with this chart. To show this, I need to go to the chart view. First, I'm going to select this 1D ongoing. As you can see, for the 1D, when the trading is still ongoing, the data is still not ended, it's showing all the data inside here. But what we want, what we expect is it start from this starting date until the trading hour end date. Usually it's 4 p.m. right, in Nasdaq. And that is one of the issue using this default chart X scale using the timestamp. Also, I'm going to show you for this 1 week. You can see this weird straight line here. So why does this happen? Because if you can see, the closing hour for the trading, it's at 4 p.m. okay, in the afternoon, and then after that the trading opened at 9 a.m. in the next following day. That is one issue that we have to tackle. Also, to mimic the Apple Stocks app, we will provide a default interval for these ticks, between these ticks and label in the x-axis, depending on the date interval, right? That is one thing that we want to mimic the Apple Stocks app for that. And other than that, for this y-axis as well, we will also mimic the native Apple Stocks app to always show 4 ticks and labels, okay, from the prices. That is one thing. So all of this problem, we have to solve that. We will make this app perfect, okay, not really perfect, but quite perfect. So in the next section, this will be more advanced. We are going to implement the custom X and Y axis marks to basically map those X-axis and Y-axis ticks and labels using a custom mapping. Okay, so let's begin. Let me select 1D ongoing, and I want to change the color scheme to dark. I want to pin this preview. Okay, now let's navigate to the chart axis data. Okay, currently the x-axis is using the date timestamp to plot the data. Okay, so we're going to basically update this so it uses index. It's based on number. It's going to start from index 0 all the way to the end. So the axis start will be 0 and the axis end will be the total number of elements in this array, okay, minus 1. And then we are going to increment this by 1, increment or stride by 1 when declaring the custom x-axis marks. Okay, and then basically we will simply loop the indicators index for showing the marks in the chart view, and using the index we will be able to get the related price in this items array. And also we're going to define a dictionary with the index as the key and the value containing the text for these axis labels. Okay, so we should be able to format by anything that we want. Okay, for the x-axis we're going to define a unique set of date components based on the selected range interval. Okay, for example, one day it's going to be, the interval is going to be by 1 hour. For example, 2 years it's going by 6 months, the intervals will be 6 months. 10 years it will be like 1 year per ticks. That is also the thing that we are going to handle. You don't need to think much about this. Now you will get a bigger picture as we implement this. Okay, for now let's update the current chart axis data struct by adding the dictionary and the strat by property. Okay, strat by, what I mean by strat by is the increment by the interval between each of the ticks. Okay, so we're going to use a double for the strat by, and for the map, this is the dictionary. So the index itself will be the key and the value will be the text for the label in this. Okay, as well on this y-axis that we will do next. Now let's go to the chart view model, and then we need to go to the y-axis chart data method. Obviously it's going to give the missing arguments as we have added new parameters, right? For now let's just put a placeholder value of 0 for strat by, and for the map let's just pass an empty dictionary. Okay, now let's go to the top of this file, then below this private let selected value that formatter. Okay, we are going to declare another that formatter. Private let that formatter. Okay. We're going to use this for formatting the value in this x-axis text labels. Okay. We will need to navigate to the chart range, and let me go to chart range plus extensions. Okay. So we are going to declare another var, computed var in here, and the name is get format with the type of string. Here, let's use switch on the self. No, I'm not going to use that. So for 1 day, the date format will only show the hour. Okay. And for 1 week and 1 month, the format of the date in the label, x-axis label, will be only showing the day. Okay. And for 3 months, 6 months, and YTD, so I need to return in here. I'm going to return the name of the month. Okay. And for 1 year and 2 year, the format of the label, the date is M. Okay. So what's the difference? So using this triple M, it's going to, for example, November will be Nov in here, and in here it will be November. Okay. And next is 5 year, 10 year, and also the max. In that case, I will show the year, the digit of the year. Okay, I think we handle all the cases. Let's go back to the chart view model. Scroll. Now, above this y-axis chart data, let's declare up. Let's just make a func x-axis chart data. And we want to also compute the indicators, the items, the array. Okay. In here, we're going to pass one parameter only, chart data, and the return type is a tuple. Okay. This one is the chart axis data. This is for the x-axis, and we also want to return the items, right? The array, which is the chart view item here. So let's begin by declaring a time zone. And basically, the chart data from Yahoo Finance API returns the time zone. It is in second from GMT, the time zone where it is currently being traded. Okay. So let's initialize the time zone and use these seconds from GMT, and then we can pass data.meta. This is from the chart data, Yahoo Finance API, and then it has this GMT offset that can pass. Okay, so this is optional. Let's provide the default value of GMT and pass it nil. Now we have the time zone that we can attach to the date formatter. So it's using the appropriate time zone for showing the hour. We can simply assign the formatter the time zone to the time zone, and then also the selected value that formatter as well to the time zone. So this is the one that we use for dragging, I think, right? And next, let's set the date formatter, that format. Okay, this is the date format that we can simply use the selected range .date format extension that we have created before. So before we continue on generating this chart axis data, we need to add several helpers method that we want to use to calculate the date components given an interval. Okay, let's go to the chart range plus extensions again. Then in here, our func get date components. Okay, so there's this parameter start date, the first one. Second one is end date, so we pass the start date and the end date, and also the time zone that we will use to generate the components. So basically this will return a set of that components. Okay, so basically for each of the cases, okay, 1 day, 1 week, 1 month, it will provide a different set of that components. For example, in 1 day we only want to have the hours, right? We don't really care about the day, the year, the month. So in that case, probably for 1 day it will start from 9 a.m, 10 a.m, 10 a.m, 12 p.m, up to 4 p.m. And also for the others as well, you will see it as we implement this. We will be using this get that components to do the calculation later, to determine whether we show the ticks in a specific index. Okay, so first let's declare a component, calendar.component. Let's also declare a value, which is an integer, and then let's use switch on self. Okay, scroll down here. For 1 day, the component that we will be using, we only use the hour. We don't care about anything. For the 1 week, we use the day, and for 1 month, we use the week of year. Okay, and for 3 months and 6 months, I can combine this because it's going to use the same component. It's going to be month. Forget to assign the value here. Value will be 1. This one also is 1. So basically this value will be the increment, okay, that we will use later between each of the ticks. Okay, and YTD is component is also month, but in case of YTD, the interval between each of the month is 2. Okay, continue with the year. For year, it's also going to be month, and the value we want to increment it by each quarter, 4 months. Okay, I think it's not quarter, it's 4 months only. Okay, a quarter is like 3 months, I think, right? And then 2 year is also we want to increment by month, and the value between each of the increment is 2 year. 6, we want to increment by 6 months for 2 year, and the 5 year we want to increment by year. The value between each of the increment is 2 years. Now it's 10 years. For 10 years we want to increment by year, and the value for each increment is 10 year. It's going out to also be 2. So I think combine 5 year, 10 year, same, right? And then max for all, we want to also use year, but in this case the increment will be by 8 years. Okay, hope all of this is correct. What am I missing? Okay, I think no, we've covered all the cases. Now let's continue. But before we continue, we need to also create the extension for that. Let's go to foundation plus extensions.swift file. Let's scroll down. Let's create an extension for the. Okay, so create a method func get components. Okay, given a time zone and range type, chart range. You need to import CSTOX API, range type, and then calendar. this case, let's provide the full value of current Gregorian calendar. Okay, and then let's declare a lab current. Let's use the calendar to have the date components. I think this one in this time zone that we have from self. Okay, because this is an extension of date, so self is date. Then let's go the var dc date component. So initialize the date components again, and then let's pass the time zone, and then we're going to also pass the year. For the year, we can use current.year. For the month, current.month. Okay. So this is all the. So I want to update my previous statement. So for all the selected range, the year, the month is required. Okay, year and month are required for all the components. And then basically here, if the range type is month, right, do we have some extra logic? Okay, here, if range type is month or range type is 1 week or range type is 1 day. Okay, so either of this is true, then we're going to assign the day using the current.day. So for all of this range type in here, day is required. Okay, 1 month, 1 week, and 1 day. And then continuing on, if the range type is 1 day, hour will be required. Okay, so only for 1 day we will use the hour component, date components. Okay, now we have the date components given a date and an interval, chart range. Okay, we can return the DC. Forgot to add a return type in the method here. It's going to return the date components. Now let's go back to this. We have to complete this method. And now let's declare the set. Okay, we're going to basically looping this until the end. Okay, so let's declare set first. Var set of date components, and then let's define the date that we want to use as a start date. So let's put this into a temporary variable date. Okay, using the start date as the initial value. Components need to add that parenthesis to initialize it. So there's one condition: if self is not 1 day. Okay, so only if not 1 day, we are going to add the first item into this set. So to do that, we are going to use start date dot date components. Okay, passing the time zone and the range type. Okay, which is self. So if you consider in the Apple Stocks app, other than the 1 day, right, they will have the first ticks at the beginning. But for 1 day, it doesn't have the first tick. Okay, so that's basically this logic is for. And then now we use to while here, while the date, okay, while the date is not less than equal to the end date, right, we will use this date with using calendar.current date. We're going to increment the date by adding, okay, by adding the component to the date, and we're going to just force unwrap this, okay, because we know this must succeed, right? And then after that, we insert the date that has been added by the component in here. Okay, so for example, if the chart range is max, it's going to add it by 8 years. Okay, I think I missed something in here. By adding component, I need to pass the value, sorry. Okay, we have the value, and then we're going to insert it into the set. Okay, Now let's finally we can return the set, I think. Oh, sorry, it requires that components. So date, we need to convert it to date components using the date extension that we have created before, passing the time zone and the range type. Okay. So now for each of the range type in here, each of the case, we should be able to generate all the set of unique date components, okay, given the start date and the end date. Okay, the start date and the end date will be obviously based on the array start date and end timestamp. Okay, that is the thing. Now let's go back to this x-axis chart data to finally implement. So bear with me if you are still get confused with this. Let's just continue hearing my explanation and see how will it work at the end. I know this is a bit complicated. Okay, now let's declare for axis that components. Okay, and basically now we can declare this set that components, initialize it, and we have several conditions. If let's start timestamp first. So if this axis data.indicators the first timestamp, the array, and if the range type, if the selected range is 1 day, okay, again 1 day. With this 1 day, we're going to assign this x-axis that components with selected range get that components. Okay, the start date will be the start timestamp, and the end date, in this case the end date will be different. Okay, it will be data.meta, will be using the regular trading period end date. Okay? This is for the 1 day chart range. Time zone you can pass. Other than 1 day, you can simply assign the x-axis data components with the selected range get that components, passing the start timestamp, and for the end date we can simply pass the, I think I show you is in here to get the end timestamp. We can get it from the last item, the array, right? Last dot timestamp. Okay. So only for 1 day we are going to grab the end date using this regular trading period end date. Okay. Now we have the sets of date components for the x-axis, all the value. Now we have to loop the data and to check whether the data at the particular index match with this date inside this date components. Okay, if this match, we are going to insert it to the dictionary and it should provide the formatted text for the text labels. Okay, let's continue. We can declare a map string, and then let's declare axis n. This will be integer, and declare items. This will be array of chart view item array. Now we are going to loop the data.indicators using enumeration, so we'll be able to get the index as well as the value in that particular element. Okay, in here let's declare that components, and we can use this indicator value dot timestamp that components. Okay, passing the time zone and the selected range. Okay, we have the date component for this particular index. Okay, timestamp in this index from the indicator. Now we want to check, right, if the x-axis date components, this set of date components, right, contains this date component. Okay, in that case we want to make this show the axis at this particular index, the axis labels, sorry, the tick labels. So we're going to add the map here, assign the map with the, let's convert the index to the string in here, equal to that formatter dot string from passing value dot timestamp. Okay, it will be providing the formatted date for the text. You may be wondering why I need to convert that index to string, right, for the key for the map, but you will understand it later when we integrate this with the axis marks later. Okay, so for now, bear with me. Continuing on, x-axis that components, we don't need this anymore. Let's remove this from the x-axis that components. Okay, continuing on, below this, we're going to make sure we append this to the array, right, to our items array. And let's initialize the chart view item. For this timestamp, it's going to be the indicator, the timestamp. Sorry, value.timestamp, and for the value, it's going to be value.close. We're going to use the closing price. Okay. And finally, for the axis end, what will be the end of the axis for the X mark? We're going to be using index. We're going to use the last index in the array. Okay, items.count -1. Okay, remember zero back offset for the array. And finally, let's initialize the x-axis data, chart axis data. Axis start will be 0, right? 0 will be the index that we're going to start. The axis 1 will be the axis end. And right by, we are going to increment by 1 index. And for the map, we can pass this map var. Okay. And I think we also need to convert this to double. You may be also wondering why I'm not using integer, right? But you will also understand it later when we implement the y-axis marks. Okay. So let's return the x-axis data and the items. Okay, now we have all the things that we are going to do to drive the custom x-axis marks, ticks and labels. But actually, we need to go back to the chart view data. Remember, we haven't declared the x-axis data here, the chart view data. So let's add this now. And then we need to go to the transform method in here. Now we have so let's remove these items. Okay, so that's why I'm returning it. I'm using a tuple, right, containing the x-axis data and the items, because I didn't want to loop this twice. Okay, so now we can just use flat x-axis chart data and the items, and then can invoke this x-axis chart data and items, passing the chart data. Okay, now we have the x-axis data. Let's pass this. Also the items. We already have it from this tuple. Nice. Let's try to build first. Make sure there is no issue. Okay, build succeeded. Okay, now let's resume the preview first and go to the chart view. We need to update this for each to use the index of these items. So to do that, let's use this zip. Okay, it accepts two parameters. It creates a sequence of pairs built out of two underlying sequence. The first one is we want the index, the indices, data.items.indices, and the second one we want the actual item in the array. Okay, and we need to wrap this to using array, convert this to array. And for the ID, we need to pass let me use the first element, which is the index. Okay, now we have two parameter in here, the index and the item in the array at the particular index. We're going to update this time to use index, and for the value we're just going to use item.value. This one as well for the area mark, index for the x, and item.value for the y. Okay, now the chart is not working because we have to update some other things. So first we need to declare a private var chart x-axis sum axis content. Okay, a type that represents the element that you use to build a chart's axis. Okay, now let's move this. We need to update this first. First, we need to declare this chart x-axis modifier, and we're going to pass the chart x-axis in here. Also, the x scale, we have updated this, so we need to pass data.x-axis data.axis start and data.axis x-axis data.axis and for the x scale. Okay, make sure to use the x1 x-axis data. Okay, now let's begin implementing the chart x-axis in here. Okay, let's declare an axis marks, and we need to pass the values here. We're going to use this stride by, and we're going to pass data.x-axis data stride by. So how many what we want to increment by. So in this case by 1, right, for the x-axis. It's going to pass the value in here, and then we need to basically determine whether we want to show the ticks and the labels at that particular index. Okay, first let's use iflet text, and we need to use the map, the x-axis data.map. This is the dictionary. We need to convert the value, this, right? So this gives us the value, and we can grab the index. Okay, remember the index itself is the key for our map, and if this particular index exists in our map, we're going to basically declare the grid line, and then we're going to write a stroke with a line width 0.3. Okay, now as you can see, we have that very thick grid line there, vertical grid line, that particular index. Now continuing on, let's add an axis tick. So with the stroke with line width of 0.3, and now finally we need to have the label axis value label. I'm going to pass this collision resolution. I'm going to pass greedy. Okay, and then inside this axis value label, I can simply declare text, passing the text from the iflet, and set the foreground color to UI color label, and set the font font caption, and set the font wave to combine this. Then combine this. It looks nice, right? Okay, let's check another chart range. 1 week. What? It's broken. I think I know why it's broken. So basically, when we stop this data in here, we haven't updated the selected range, right? So that's why it's using 1 day. So here inside this chart view model, just make sure to assign the chart vm.selected range with the range from the parameter. Okay, now it's working fine. For 1 week, it's using the date here, 31, 1, 2, 3. Let's check 1 month. Okay, 5, 12, the interval is 7 day, right? 19, 26, 2. Also previously the 1 week is broken, right? There's a like straight line. Now it's working fine. So now, because we are using every element, the index, now this is correct. We don't have that straight line. This is nice, looks great. 3 months, August, September, October, 1 year, November, March, July, November, May, November for 2 years. For all, it's going to be 8 years, 84, 82, and 92, 2000 up to 2016. Okay, this looks amazing. Nice work. But this is still not working. Okay, we have to basically handle this properly. So this is very easy to fix. I will tell you why this happened. Okay, so this happened because in here we only looked until the end of the array, right, in these indicators. But in case of ongoing trading, the last date won't be the closing hours, right? So you have to add additional looping in here for the ongoing 1 day, right? Okay, so if the selected range is 1 day, comma, let's use par date items. Just grab the last date in the array, item.last.timestamp, and let's use this date greater than equal to the data.meta.regular trading period started. You have to make sure that it is within the range, and date dot that is less than equal to, not less than data.meta.regular trading period ended. Okay, so while these conditions are met, then it means that the last item in this array is still within before the trading period ended for ongoing trading day. Okay, so we're going to look while the date is equal to the closing trading day start end date. We're going to increment the axis by 1. Okay, and then we're going to get the date, update the date with the calendar current date by adding minute. Okay, we're going to increment by minute in here. We're going to increment by 2 minutes to the date. Let's just force unwrap this, and let's grab the date components in here. Date components using the time zone and the selected range, and let's also check if the x-axis date components contains this. Okay, then we're going to put it into the map. Okay, the sysn and the value, we need to format it using the date formatter, string from date. Okay, and let's remove the element from the component set. Okay, we have this. Hopefully there is no error, and let's see the result. Nice, it's working, right? So currently the last item, the last price, the array is like around like 10 a.m. right? But the actual closing hour for the particular day is at 16. So that's why we still have this gap, right? And this is the behavior that we want to mimic from the native Apple Stocks app for 1 day ongoing. Nice. So yeah, basically we have implemented the custom x-axis marks, right? With this custom formatting for the labels for the date depending of the chart range. Amazing. This is one of the technique that I learned by just doing a trial and error, right? And finally I can basically mimic the one that Apple uses, right? Now we have to move to the final part, which is the custom x-axis marks. We're going to basically show 4 tick labels for the y-axis. Okay, so we have to do some division from these prices in the rate. Let's do it. Okay, let's begin by navigating to the chart view model. So we already have the y-axis chart data method. Okay, so we need to update this with a new logic to provide 4 ticks and value labels in the y-axis marks. Okay, let's begin. First, let's define our lat diff. We need to find the difference between the highest and the lowest in the y-axis. And next, let's get the current number of lines that we want. In this case, we want 4 lines. Okay, and let's also declare this parameter. Should we sell the increment, whether it should be rounded or not? It will be a boolean. Okay, and stride by increment by how many? It's a double. Okay, so there will be a condition that we need to tackle, and it will provide different value. So first one, if the diff between the maximum and the minimum is less than the number of lines, right? Then we will set the should sell increment to false and set the stride by increment by 0.01. Okay, so it is less than 4. Okay, else we'll set the should sell increment to true and set the lowest. We're going to round this down. Okay, lowest, and the highest we're going to round this up using sale highest, and stride by we're going to increment by 0.1. Okay, let's go to foundation plus extension to create some helper here. Above the date, let's create the extension for double. This will help us to format the number. For rounded string, we want to round it by 2, format by 2 decimal point. You can simply invoke string format person string person.2f and self. Okay, we have that. Let's go back and let's also create another helper method in here. Format y-axis value label. What's the value here? So parameter double should sell increment. We will pass this to this method. This is a boolean. This will return a string. Okay, if should sell increment is true, we will return string, and basically we will just use integer, okay, to remove the fraction, and then call sale to the value. Okay, else we're going to return using this utils number formatter that we have created in the previous part. We're going to format this passing as number of the value. Okay, and if it fail, we're just going to use this value.rounded string. Okay, I missed this closing parenthesis in here. We don't need the parenthesis in here. And now let's go back to this y-axis chart data. Okay, and let's continue here. So let's create this lat increment. Okay, let's put this parenthesis highest minus lowest. Okay, we're going to remove highest means lowest, and then we're going to divide it again by the number of lines that will be the increment. And let's declare the map to be string dictionary, and then spell the first one, highest will be the first one, rounded string, we're going to round it up, and then format, all the format y-axis value label passing highest and the short cell increment. Okay, and let's prepare this temporary var current lowest, and then we're going to use this range 0 0 and this half range, and then int number of lines, and then minus it by 1. Okay, and then call for each, and then we set the current, we're going to increment this, and then we're going to set the map. Okay, short cell increment is true. We're going to sell the current, else we're going to use just the current as the key, and then there's all the rounded string again in here, and then we're going to assign it with format y-axis value label passing the current value and short cell increment. Oh sorry, this one I think. Okay, this is the correct one. So basically that's it for the y-axis mapping. Okay, we have divided it by 4, and then done a custom stripe. If it is the difference between highest and lowest is less than the number of lines, then format the number in here. Okay, and now finally we can turn the chart x-axis data in here. We need to pass the stride by and the map, and next we need to go back to this chart view. Below the chart x-axis, let's set another private function, chart y-axis sum axis content. Okay, here let's add the chart y-axis, passing this chart y-axis. Okay, this is not a function, this is a var. Okay, so let's declare the axis marks here. We're going to add the preset as extended. Okay, and we're going to set the values as stride by data, y-axis data, stride by. Let's grab the value in this closure, and now we need to cast this value to double value as double.self. Okay, that value is a floatable value, and then we need to check whether the text exists in the y-axis data map. Okay, and for the key we can use this y. Let's round this first, format this to 2 decimal point string. Okay, if this exists, we're going to render the axis grid line. So for the axis grid line and axis tick, I can just copy from the x-axis mark. And next is the axis value label. Okay, here we need to make some change. Okay, first we need to set the anchor to top leading and set the collision resolution as greedy. Okay, and let me scroll a bit. As you can see in here, let's set the value back to the text, and then foreground color with the color UI color of label, and the font bold. Okay, hopefully this works. Okay, now we have these 4 fixed labels in the y-axis, so it's not evenly divided in here. So maybe if you want to perfect the calculation for that y-axis data, you can, but in most cases I think it works fine, right? This is 1 week, This is a 3-month, YTD, 2-year. All of them have this evenly distributed by axis interval. Okay, I think that's it. We have implemented the custom y-axis marks as well. Now there is one thing that is currently broken actually. So currently the drag is not working, right? Because we have updated the selected X. We are not using the timestamp, but we are using the index. So we need to do some update to fix that on drag. It's not too much. So basically in here we need to change this logic, this iflet. So we're going to change to iflet index double. Okay, we're going to ask the chart proxy value at X. Yeah, it's current. We're going to make sure the index is greater than or equal to 0, and let's cast the index to integer. Index is less than equal to the data.items.count.-1. Okay, so make sure they are within the boundary of the index, the range of the index in the array. Self.pm.selectedX, let's just cast this index as integer. Sorry. Now we have to update the selected X rule mark in the chart view model. Down here, we're not going to cast this as date anymore. We're going to cast this as integer, and we don't need this date beans anymore. Okay, no need for that. We can basically simply use this. Even this we can refactor, right? Because we have our that extension for double, right? Selected X dot get the value, then call rounded string. Okay, and next one is selected X that text. Oh, sorry, this one should be, we also need to update this to integer. Okay, value integer. And the next one is, there's no error again in here. Okay, selected X that text, this is also being casted as date. We need to change this to integer. Okay, and basically here we don't need this date beans anymore. We can use the selected X, the actual index in here, and it should work now, right? Now let's try to test this. Let's try to build first, make sure there are no errors. Let's go to the stock ticker view to test this. Resume the preview. Let's remove this pin. Okay, let's drag, hold left click. Nice, it is working as expected. Amazing. Let's check this one day. Okay, I think we're at the end of this tutorial series, and one thing that I want to show you is, let me try to run this. Okay, so let me give you a recap of this entire series. In the first part of this video, we have implemented the Swift Package Manager to fetch the data from the Yahoo Finance API. And in the second part, we have implemented an ability to search stocks, as you can see in here, and add it to the list. So this will be persisted to disk. We have showed this latest price, the difference, and in the third part of the video, we have implemented this stock ticker sheet view. As you can see in here, we have all of this information, the details of the quotes in here, and in the final part, we have implemented this chart view. There are a lot of things with this custom x-axis marks, y-axis marks, as you can see in here, as well as the ability to drag and show this annotation or rule mark annotation, right? So as well as of this previous date close rule mark, a lot of things we have implemented in this video. And yeah, I hope you learn a lot of things by watching this video. I know I won't be able to explain everything in details, right? But I hope this will be the foundation for you to learn about Swift charts going forward and to implement your own charts based on your use case. There are so many other charts that we can create with Swift charts, and it is very amazing to have for Apple to provide this kind of framework, right, for us to use a native framework to build charts. And that's basically it for this series. So until the next one, I want you to keep on being a lifelong learner. I know currently we are in a very bad situation in terms of the global recession and economy, but I hope in the future it will get better. We will have better future, we have better economy, and not much we can do for now other than just keep improving our skills and keep growing, preparing for the worst, provide value to the community, to the others, helping each other as well. So that's it, and until the next video, goodbye.